Hi Lakers, this video is to guide you through how we can model real life data. So here are the temperatures in a table and a graph of Cape Town, South Africa. And this data is from 2010, months in 2010. So yes, data is outdated, but we are going to use it to create a model. So notice that we start in January and end in December. And so these represent the months after, this would be first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and then the 12th, and then the next month would be January again. So looking at this graph, what we want to think about is one full wave. And so notice that we are starting close to the maximum height. It's almost over on the y-intercept. And this would be another place to consider a maximum height. And notice that that is 12 months, 1 year. And then the next thing I'm going to consider is the average between this maximum and say this minimum temperature, because that will help me find the midline, that principal axis. Let me zoom in, excuse me. So looking at this minimum for the 7th month, we have 15. And then notice that in the 19th month, it repeats. But the maximum temperatures on the 1st and the 13th, we'll use 28 and 26. So I'm going to use 28 and 15, finding the average of 28 and 15. And when we divide that 43 by 2, we get 21 and a half. And so 21.5 degrees will be our principal axis. I'd encourage you to reach for your ruler and draw a nice straight line. Excuse me. What we're going to estimate is where is that 21 and a half? And we want to make sure that we are visualizing between that minimum and that maximum. So I'm going to estimate it right here and draw in my principal axis. And about 21 and a half. Okay, now, because the highest temperature also known as the max, is close to the y-axis, we will use a cosine. One last thing I forgot about the amplitude. What we want to look at is what is the height from the principal axis to the maximum, or that principal axis down to the minimum. And if we look at the maximum and we used 28, what is 28 minus that 21.5? Well, that is about 6.5 degrees as an amplitude. Okay, now to write the equation, we also need the b. We need to know how many waves of 12 months are in 360 degrees? That is the big question we need to answer. So if we think about one wave in 12 months, convert that to 360 months. Okay, how many of those waves would it take? So 12 times that B will get us to 360. And so what we're going to do is divide 360 by the time that's in one wave. And what we should see is about 30 waves. And what that means is our B is 30. Because we can put 30 of these 12-month waves in a full circle of 360. Now, what we're going to do is write the equation and then plug in some temperatures, or plug in some time, to see if the temperatures work out. So the equation, y equals a times the cosine of bx plus our c. So here is our equation using our amplitude at 6.5. Cosine of 30x plus 21.5, our principal axis. Now the first x value that I'm going to plug in, I'm going to plug in 2 months. 2 months and 27 degrees Celsius is what we should expect. So plugging that in will look like 6.5 times the cosine of 30 times 2, and then we add 21.5. Let me show you that calculation. First of all, mode. Make sure you can see degrees. Then I'm going to type in the calculation. 6.5 cos, notice parentheses, 30 times 2, or you could have typed 60, and then plus 21.5. And we get 24.75, 24.8 if we rounded to 3 sig figs. And so actual is 27 degrees, model 24.8 degrees. Model is 2.2 degrees less than actual. So for the month of February, it underestimated the temperature of what it actually is. But now let's try maybe November. Notice November was getting back up because in this region of the world, summer is at a different time. So summer is in those later winter months that we would have really rigid, cold temperatures. Frigid, yes. And then, so plugging in 11, we would expect to have 24 degrees. Let's see what we get. 6.5 times the cosine of 30 times 11 plus 21.5. Sorry, forgot to show you this. So now instead of 2, I'm going to substitute 11. So you have 6.5 times the cosine of 30 times 11, and then add that principal axis. And we get 27.1 degrees. So in this case, the actual was 24 degrees, but the model was 27.1 degrees. 3.1 degrees over actual. Okay, now I would argue that there is a low error percent. For example, if we looked at 2 and 27, if we compared the actual, which would be 27, the estimated would be our 24.8, and then the actual divided by 27. When we multiply this by 100, we get an error percentage. 27 minus 24.8, and dividing by 27, and then multiplying by 100. You might argue that that is a lot of error, actually. That's 8.15% error. Maybe low or somewhat low percentage error. 8.15% error. That's an R. And so I would say this model is okay to use for predictions. We will just be mindful if we made a prediction for, say, in 2022 or 2023, that we have a little bit of error. Some were over and some were under based on our model. Thank you for watching this video. Please use this video to assist you as you practice with Southeast Asia, or Southeast Australia, excuse me.